Would you take an anti-aging molecule? You probably didn't know this, but scientists have been extending the lifespan of animals with a substance called rapamycin, a substance found in a volcano on a remote island. We've been testing rapamycin on lots of different animals, and it's extended the lifespan of every single one we've tried it on. In mice, it increases lifespan by 9 to 26%, which would be like adding at least 7 to 20 years to human life. And now, thousands of lifespan maxers have taken it because they are convinced it can extend their own lifespan. But before you pay $65 a month to live longer, we need to ask one very important question. What was this drug doing in nature? Rapamycin was discovered in 1972, produced by bacteria called Streptomyces hygroscopicus, living inside volcanic soil on a remote island where people really liked to build statues. The locals called the island Rapa Nui, and the molecule was named rapamycin after it. In high doses, rapamycin was found to suppress the immune system, which made it useful for organ transplants. Basically, it calms down your immune system so your body doesn't reject the new organ. It also slows cell division, and that's actually what the bacteria were using it for, to stop other organisms around them from growing. Rapamycin was basically this microbe's biological weapon. But why would a bioweapon stop growth? Scientists have been extending life for 90 years. In this 1939 study, these two lab mice are the same age, but one looks much younger. That's because it was on caloric restriction, meaning it was underfed and lived up to 40% longer than its well-fed friends. Everything from yeast to humans follows the same logic. Grow when food is plentiful, survive when it's scarce. That's why you take protein after a workout. You're signaling to your body that the environment is full of food, so it's time to grow. A major part of that signal comes from a nutrient-sensing pathway called mTOR, mechanistic target of rapamycin. mTOR senses the sugar and protein you eat and tells your cells to divide. But if you stop eating, you could gaslight your body into believing that there's a famine, and it switches into repair mode to survive until food returns. Here's a 3D rendering I made using X-ray diffraction data. You can see rapamycin binding to a part of mTOR and inhibiting it. It convinces your body there's no food, so it stops growing and focuses on repair. And that process seems to extend lifespan. In other words, I'm going to die early from eating $87,000 worth of Taco Bell. We know that aging is the variable most highly correlated with disease, so anything that slows aging could reduce all diseases. So, can you take a magic pill to do that? mTOR actually comes in two complexes, Complex 1 and Complex 2. When taken intermittently, rapamycin inhibits Complex 1. When taken chronically, it also inhibits Complex 2. We only want to inhibit Complex 1. This lets us get most of the longevity benefits, but with less side effects. That's why lifespan maxers take 3 to 10 milligrams once per week, though it varies by sex, weight, and genetics. The most common side effect, mouth ulcers. Annoying, but not dangerous, and they often go away after a few months. So does rapamycin extend life in humans? It'd be pretty strange if it worked in every organism ever tested, and then suddenly didn't in us. That's why researchers are frustrated by the lack of funding. You can't patent rapamycin, so there's no big money incentive. Some scientists have even crowdfunded their studies. One doctor literally mortgaged his house to fund a human trial, which is not something I'd ever consider doing for any of my experiments. These studies will answer key questions. What age does it work best at? Are effects more noticeable for elderly people with overactive Complex 1? If it slows growth, will it kill your gains? Can we design a cleaner drug that hits only Complex 1? All of this is still being explored. Ultimately, rapamycin should only be prescribed by a doctor, who can run blood tests and decide if it's appropriate for you. They can also tell you when it's not a good idea, like right after a joint replacement where you need cell growth for healing. There's a lot we don't know, which is why there are so many human trials happening. But we do know that you can already modulate the mTOR pathway naturally by eating nutrient-dense food and not too much of it. Because aging isn't fixed, it's adjustable. What do you think? Did I get it right? Peer review me in the comments.